Hello, my dear students. This is Dr. Mohga, and today we'll be talking about mass and weight. The content we need to cover is we need to know what is mass, what is weight, their relationship with gravitational field strength, and we need to know how are they measured. Mass is the amount of matter in an object. For instance, your heart, your liver, your bones, your brain, your skin, all of this is the matter inside your body. So this is the amount of matter in an object. It's measured using a balance, meaning that when I have my mass, if I'm on Earth, I'll have, let's say, 60 kilograms. If I go to the moon, did anything inside my body change? I left my left leg behind, right leg behind? No, of course not. So whatever is in your body in any place stays as it is. So your mass on Earth is the same as your mass on the moon, is the same as your mass in a hallway, on top of a mountain, inside your house. Your mass never changes. Since mass has no direction whatsoever, it's a scalar quantity. It's measured in kilograms or grams. You must be able to convert kilograms to grams and vice versa. Kilograms to grams, always when we're converting from the large number to the small number, or from a large quantity to a small quantity, we always multiply. So from kilograms to grams, we multiply by 1,000. On the other hand, from grams to kilograms, we divide by 1,000. Now let's talk about weight. Weight is a gravitational force on an object with mass. Gravity on Earth is with direction, like we're always pointing gravity down towards the core of Earth. So since we have direction, it's a vector quantity. When we want to put them in an equation together, weight is equal to mass times the gravitational force. So if we want to switch this equation around and we want the gravitational or force or gravity to be our main object in this equation, gravity will be weight over mass. Bear in mind that weight is measured in newtons, mass is measured in kilograms, hence gravity is in newtons per kilograms. Since weight depends on gravity, and you know that each and every single planet has its own gravitational force, hence the weight changes depending on the place you're in. So on Earth, your weight will be different than on the moon, will be different than on Mars. We measure weight using a scale, and it's measured in Newton, but be very careful that if your mass is in grams, you have to convert it to kilograms first before you find your weight. So mass must be in kilograms, not grams, in order to find weight in newtons. If a person has a mass of 30 kilograms, what's his weight on Earth? We're going to multiply mass times gravity to get the weight, which is 30 times 9.8. 9.8 is the number which we take for gravity, and it does not change on Earth. So always on Earth, gravity is equal to 9.8. So weight will be 30 times 9.8, giving me 294 newtons, and we prefer having two significant figures, so that's approximately 300 newtons. Here's an example. Pause the video, try it on your own, and then unpause. NASA's Artemis mission aims to send the first woman astronaut to the moon. Isabel hopes to one day become an astronaut. She has a mass of 42 kilograms. Compare the difference between Isabel's weight on Earth and on the moon. Take the Earth's gravitational field strength as 9.8 newtons per kilogram and the moon's gravitational field strength as 1.6 newtons per kilogram. Now that we have the mass, that does not change whether she's on any planet, so we can use the same mass to compare Earth with the Moon. Knowing that the gravitational field strength on Earth is 9.8, we can easily get the weight by multiplying mass of 42 times gravitational field strength of 9.8 to get the weight. And on the Moon, we'll do the same thing, multiply the mass of 42 by the gravitational field strength on the Moon of 1.6 to get the weight. Here's the answer. As you can see, on Earth, the weight is 410 newtons in two significant figures, and on the Moon, the weight is 67 newtons in two significant figures. Conclusion: the weight force is greater on Earth than on the Moon because the Earth has a larger gravitational field strength than the Moon, so Isabel's weight force is larger on Earth than on the Moon. Let's try this example. Pause the video, try it on your own, then unpause. Which row contains two correct statements about the mass and the weight of an object? A. The mass of the object is measured using a measuring cylinder and the weight is measured using a balance. Of course, this is not correct because we use a measuring cylinder to find the volume and we use a balance to measure the mass. B. Is the gravitational force exerted on the object is the quantity of matter in the object. This is not correct. Actually, the definitions are the opposite. Mass is the quantity of matter in the object, and weight is the gravitational force exerted on an object. C. Mass is measured in newtons, weight is measured in kilograms. Wrong, because they're exactly the opposite. Mass is measured in kilograms, and weight is measured in newtons. D. Mass is the same everywhere. Weight can vary from place to place. This is the correct answer. D. Thank you so much. See you in the next lesson. Have a good day.